Well, good evening and welcome to the sixth program of the World Affairs Council of Western Michigan's 2021 8-week Great Decisions series with topics suggested by the Foreign Policy Association of America. I'm Michael Van Denen. I'm the Executive Director of the World Affairs Council. And on behalf of my colleague Eric Ukpeaġvik and the Board of Directors of the World Affairs Council of Western Michigan, I welcome all of you. Thank you for adjusting with us as we program responsibly during this time of the COVID-19 pandemic. We hope you stay well and that you show grace to those in your community. The Council's mission is to empower the people and organizations of West Michigan to engage thoughtfully with the world. We do this with the help of 50 local companies, 11 colleges and universities, and many community partners. Together, we seek to provide programming that is credible, objective, relevant, civil, and compelling. To change the world, we believe, one must first know the world. Tonight, we say thank you to Wolverine Worldwide as our series sponsor, and to Blue Lake Radio and the Community Media Center as our media sponsors. After the presentation this evening, there will be ample time for questions. You may type them into the YouTube comments section or text them to 616-308-6560. Please exhibit civility to our guests and hospitality to others by asking respectful and succinct questions. We're pleased to have Kaare Sikuaq Erickson and Bob Hollister with us, and we are very grateful to them for their flexibility to engage us in this manner. Kaare Sikuaq Erickson is the North Slope Science Liaison for the Ukpeaġvik Inupiat Corporation in Utqiagvik, Alaska, formerly Barrow, Alaska. As liaison, Erickson represents hundreds of Arctic researchers to thousands of Arctic residents and vice versa. His day-to-day responsibilities include providing advice to Arctic research projects during all phases of these projects, and facilitating research and outreach and engagement initiatives in communities in the Arctic. He also serves on the board of directors for the Arctic Research Consortium of the United States. Dr. Bob Hollister leads a collaborative multidisciplinary research project funded by the National Science Foundation as part of the Arctic Observatory Network. He began Arctic research in 1995, working in Utqiagvik and Akasuk, Alaska. These sites are now among the longest continually monitored vegetation sites in the Arctic. He is currently co-chair of the ITEX, the International Tundra Experiment Network, and he has worked with many research groups from around the world. He has experience working in systems outside the Arctic Circle as well, especially Michigan wetlands. He also teaches about climate change and other environmental issues at Grand Valley State University. The presentation tonight is titled The Warming Arctic, and we welcome Kaare Sikuaq Erickson and Bob Hollister. Welcome, gentlemen.
Thanks for having me.
Thank you. Okay, well, just a teeny bit about me. You just heard a little bit about me, but I really started just as a grad student and loved it and kept doing it. So it's really neat to go to the Arctic and work with local communities and see the changes that are happening there now. So I've got a little PowerPoint here. I'm doing this share screen, just takes a second to do. We've all heard about the warming. If you look at this, you'll see, so this is projections for the end of the century. Most of the warming, or the largest amount of warming, is in the Arctic. And you probably already knew that, and that's probably why you tuned in today. So here's, a second. There we go. So one of the things that you've probably heard a lot about in the news is the sea ice declines. So here's just kind of looking at the sea ice. The this has been in the news a lot. I just added the recent dot to the graph. 2016 was the lowest sea ice extent year. But I like this graphic a little better. It's not as pretty, if you will, but you can see in the bottom here. I don't know, do you guys see my mouse? Yep. So you can see here that there's not very much old ice anymore. And Corey could tell you all about this, particularly if you're out whaling. If you're on ice that you used to, when I first went up, there was 10-year-old ice. And now there's barely any ice that's more than 4 years old. If you're on 4-year-old ice or 10-year-old ice, you're not worried about falling through. If you're on 0-year-old ice, it can be dicey. So there's huge implications. And if people would fall through, then polar bears would fall through, and there's other critters would too. But it's changing. Okay. You've, I'm sure, heard a lot about glaciers in Greenland and in Antarctica. And you can see here, this is just the most recent data showing that there's a lot of melting happening, and it's happening at very high latitudes as well. An interesting thing about this is many of these really big glaciers here are actually underwater. They're fjords, and you can actually have melting throughout the winter, which is kind of crazy to think about because it was super cold, but because you've got warm ocean waters, you could actually have melting year round. You don't usually see that until the spring because the top would still be melted or still be frozen, but then all winter it's kind of eroded. Some other things that you may not have seen are on land. I'm a botanist, so I'm focused on land during the summer. And this is an older image, but I really like it because you can see all these black dots. Those are lakes. And what's happened is as the area is warmed, it evaporates a little more, but that's not really the story here. We have these lakes disappearing because what's happened is the permafrost, that permanently frozen land that's frozen, that's really hard and really hard to erode. Is that thaws, it becomes mud in a lot of cases and is easy to erode. So what's happened is the whole landscape is drying to some extent. And you can see here, this is an old image, but there's lots more studies. This is just one of the better pictures showing there's just fewer lakes. Again, massive changes happening. As a botanist, someone interested in green plants, these are taken from satellite images, and this is only looking at kind of the tundra, if you will. So all the glaciers are removed and all the tree line and stuff is removed. And you see that the greener is greener and the browner is less green. And in general, it's greener, but there are some places that are browner, and that's probably from drying. But northern Alaska, so again, we're looking from the North Pole. So here's Santa Claus over here, and here's Alaska, where we're doing our research, or where I'm doing my research, and where Corey's based out of. It's really a lot greener. So why does this matter? So in a general context, if the Arctic changes, everything else changes. Because if you think of the Earth as this conveyor belt here, we've got the heating at the equator, and then it's cold at the poles. The hot moves from hot to cold, and if you change that cold, everything in between changes. So, and we call that climate change. It doesn't have to be global warming. That's just the change is actually the bigger issue. We've all heard about the polar vortex. We've had one event already this summer or this winter. Heck, we might get another one tonight. But this has global implications. Now, if we look at the kind of general changes in the Arctic that have, other than, our polar vortex, that are really important to you and me living in Michigan. One of the big ones, and this explains why the Arctic is expected to warm so much more, is just this positive feedback where you have less snow, less white, so less snow and ice, and snow and ice reflect energy away like big time. So you see the data here is 80 to 90% of the energy is reflected back. We call that albedo. If you change that to land or water, it's the reverse. 80% is absorbed, and only 20%, 10 to 20% is reflected away. So as it gets less white, it gets warmer. As it gets warmer, it gets less white. I could do this for a while. And that's why we have so much warming in the Arctic. And that's why the warming is more in the spring and fall as well. What a lot of people don't recognize is as you get taller plants, and this could be tree line moving north, this could be shrubs getting bigger, this could even be grasses sticking up out of the tundra, they absorb more heat, and particularly during the winter, because they really don't get that much snow in much of the Arctic. So usually you have a fairly thin, anywhere from, it depends more on the landscape, than you only get inches of snow. It's just where it accumulates. So it could accumulate to be, lots of feet of snow if it's a depression, but some of these tops of areas might have no snow during the winter. So if you've got plants that stick out, they absorb heat all winter and also during the summer. So again, the taller the plants, the more it gets warm, the warmer it gets, the taller the plants get. So it's a big positive feedback. And one of the ones that I, in particular, I'm looking at. Another one you've probably heard about is emissions of carbon. So we've got, I don't know, this is necessarily the best picture. This really shows coastal erosion as well. But the ground here is really, really rich, like black dirt. And if you're a gardener getting excited about planting in the spring, that black dirt is really full of organic matter. And the soils of the tundra have essentially as much or more carbon as there is in the atmosphere. So as you start to release that, as the carbon breaks down, is metabolized, it goes to the atmosphere. And that can be, it's hard to say, but that could be a massive contributor in the same order of magnitude as all fossil fuel burning. So once that starts to warm and release the carbon, then it results in further climate change, which makes it warmer, which keeps going. So that's why the Arctic is so important, and that's why there's been so much research on it. When I first started in the 90s, and at that time, climate change was settled science, and people expected that where we'd see the most impacts would be the Arctic, and we have. And so let me just put this in a paleo perspective. So thinking of going back in time. So remember, the Mesozoic is your dinosaurs. And this is just showing, I have a lot of people say climate change. Well, climate change has been bigger in the past. What's the big deal? Well, that's true. Climate change was bigger in the past. If you go back a really long time, we actually define our paleo times by climate change because they're associated with mass extinctions. I'm a biologist, so I don't want to be a mass extinction. But if you look at, where we are, first off, this line, the dotted line here, that's the difference between world without ice and world with ice. And we're in that world with ice. But we might be flirting with the world without ice. So if you kind of look here, you can see that's the warming we've had. This is what we might expect. So there's a range there, which again might flirt with the world without. But if we just zoom in on the very recent, just zoom in just there, this is what a lot of people point to is the kind of analog of our climate change that we're expected to see. So this is global climate change, and this is global paleo, this is projected climate change, and then our paleo. And you see that the numbers match up about 3 million years ago. If you look at the Arctic, it was very different 3 million years ago. There were, saber-toothed tigers and, these camels and, woolly mammoths and trees. And, you kind of got to scratch your head and say, well, it was more than 3 degrees warmer to support all these, critters. And you say, well, wait a minute, maybe that was plate tectonics. No, that wasn't plate tectonics. The plates were, pretty much where they are. So the Arctic really got a lot warmer. We need to figure out how that's happening, what's going to happen, in the next 100 years. I don't expect woolly mammoths to appear, and well, we might genetically engineer them, but there's going to be massive changes. So the point is, we're trying to study those massive changes. As an aside, the only way they can get the climate to match this is to put in the climate models no sea ice during the winter. That's kind of like, when you think of, the Great Lakes freezing or not freezing, totally changes the climate. Anyhow, so I'm looking at the vegetation change in simple terms. You could, I just did a mountain because it's easier. You can see that all the biomes move up. Well, the tundra can't move up. And in reality, we know that it won't just all move up. There'll be a lot of mixing. So the question is, how will that happen? Just as a fun aside, here's my project is the ITEX AEON, so the International Tundra Experiment. So it's a bunch of tundra people getting together, do similar research, and we're funded as part of the Arctic Observatory Network. We're at Ukpeaġvik and then Akasuk. And then we also compare our results at Toolik Lake. So we're kind of looking at a latitudinal gradient. Quick summary, big changes, less white, more plants, carbon release. That more plants can be tree line moving north, it can be shrubs and getting bigger, can be grasses and so forth. And we want to see how that changes. And so that was my quick overview, and I'll turn it over to Corey. And I'll hit stop share.
Thank you, Bob. Yeah, Koyanokpak, that means thank you a lot in our native language up in on the northern Alaska, and especially for inviting me to speak with you. I know that you were approached to speak, and it's an honor to be asked to split the time with you here. I'll just go ahead and start sharing my screen, and I'll kind of introduce myself. So Bob kind of talked about how the big effects and how kind of the global warming is kind of impacting folks in other parts of the world. For instance, you guys. I'll kind of talk more about the local perspective of being a Indigenous science liaison, kind of just some kind of general aspects of it. Today, I'm hoping to kind of introduce to you like what we do as Indigenous science logistics providers in the Arctic, and talk a little bit about a paradigm shift that has been kind of going on in Arctic research that is seeking to push for more actionable and more inclusive Arctic research, which, by the way, ITEX is a good example of long-term research building, on generational research and kind of building on previous relationships. And then I'll talk a little bit about the local perspectives of kind of bringing it down to a on-the-ground perspective of the threats associated with the warming of the Arctic, both from a logistics provider in Arctic research and also a kind of a local who has grown up in the Arctic and lives up in Alaska. I'll use 3 examples of villages that I know more about, just so that to talk about how folks might be mitigating some of these threats that are being increased from global changes. So first of all, it's important in our traditional culture to always introduce ourselves thoroughly to people, because Alaska is so huge and expansive, and we have just an incredible amount of different cultures. We always make sure to tell them who our parents are, where we're from, and so I usually start off presentations this way. And so I kind of grew up across Alaska and kind of the northern and western areas. So I was raised in the kind of the northern Bering Sea region of the Bering Straits and the Norton Sound, mostly in Unalakleet, where my dad was from. He's a Norwegian school teacher and commercial fisherman. And I was also raised in Savunga for a couple years, and then St. Michael for 6 years, growing up with. And here's me and my brother growing up in the village. My mom is from Barrow, Utqiagvik, and that's kind of how I got worked for the corporation up there. But we also have a lot of relatives in Shishmaref, and my wife is from Shishmaref, so I have relatives on both sides there. So just to kind of show you guys again kind of where we're the neck of the woods that we do work in. And I know that the image here and also the image earlier kind of shows it really green up here, but there is the vegetation that Bob was referring to is pretty short. So the tree line is down here somewhere. So we don't have any trees up north, although it does show a very dark green on the map. But then we call it the satellite village that works outside of Utqiagvik is Utqiagvik, where we have worked with Bob and in other science projects to engage with the community. If you were to hover above the northernmost point in Alaska, you would see that the village of Utqiagvik here is kind of if you were hovering in a drone or in a helicopter here above the village of Utqiagvik, looking north, this is the northernmost point of the United States. We inherited the Naval Arctic Research Laboratories that were originally created to look for oil for the Navy's new gas-powered fleet in the 20s and 30s, following World War II. World War I. World War II is when they actually built this 1,000-man campus. It was known as kind of the Cape Canaveral of Arctic research for 30 years. When the Navy and folks were going to pull out, we kind of inherited the infrastructure, and then we also got more facilities built as well, so that we kind of fell into this niche of having infrastructure, but then also being an Indigenous owned and operated science logistics business who utilizes we really like to specialize in utilizing traditional knowledge and local knowledge and kind of those formerly or previously established relationships with the communities, kind of the families we have, to really engage scientists with the communities properly. And it's been a pleasure working with folks like Bob and others who make it really easy for us to do that kind of thing. And in a lot of cases, the scientists even have deeper or go back further with some of the communities that folks like me, for instance, work with. So it's a real honor to work with all the different multitude of scientists that we work with, from the guys studying how to land on Europa, one of Jupiter's icy moons, to hosting the Navy 200 miles offshore for their submarine exercises, to hosting terrestrial researchers like Bob and others. But our specialty really is rooted in that Indigenous knowledge driving things, that local knowledge and kind of the expertise. We do have a lot of science that goes on, and this is including all the science that has kind of gone on previously for this site picture here. And I think it includes around 25,000 research sites just in the vicinity of Utqiagvik. So this is a kind of a spot, it's very unique, I would say, in the world, where you have these deeply rooted connections between the Indigenous community and visiting scientists, and you have the infrastructure that's actually owned by the locals as well. And the paradigm shift that I wanted to refer to briefly is that, we all, like some of the things that Bob was referring to about these big changes that we're seeing, folks expected to see these major changes in the Arctic. It is becoming more and more true, and you guys, have noticed that it's happening across the world, and not only in the Arctic, but it's really making big impacts across the world as far as global change. I can only speak on behalf of our neck of the woods. Things are just incredibly variable now across Alaska. But there's this kind of pressure on the scientists to make their science more actionable, to engage local communities more early in the science process, not just come in to share hey guys, we found out this and that about the sea ice, and here's our research. Use it to your, benefit. That kind of end of the science process research, or check the box outreach, or kind of doing the broader impact kind of things, is kind of, we think that we're moving past that generation and moving to an area, to a time where we're really trying to engage scientists at a deeper level in the research process, and folks like National Science Foundation and others are making that available through shifting their the calls in their Arctic research funding, like the Navigating the New Arctic, for instance, where they're really calling for folks to really engage early on. ITEX, like I said, the International Tundra Experiment with Bob and others, is an example of folks that really do utilize this generational research. And by what I mean by that is that funding of Arctic research is very temporal. It comes in 3 to 5 years, or you could get a year funded, or it's these very temporal timescales of Arctic research. But at the same time, they're saying that you have to engage with the communities at a very deep level, and what that means is that you have to develop relationships. And you guys may know that relationships don't necessarily fall within the time zones of a time scales of a project. Okay, I got 1 year to create a relationship, let's pick up the phone and create a relationship. It doesn't really work that way. So that there are some scientists and some groups out there that strategically build on previous projects where it kind of just builds and builds, and they kind of focus in on one area. And one way that I've noticed that ITEX have done that, and was to find ways to keep it funded. And one of those ways was to create equipment that doesn't cost millions of dollars, for instance. So that's one thing that I really like about the ITEX group, is that you guys have found these ways to take these consistent measurements over a long time scale, and then make it doable for a lot of folks. So kudos, and I really enjoy that about you guys. So going back to that kind of push for engaging the communities, my job is to engage scientists with the communities. Like my intro said, representing thousands of Indigenous residents to hundreds of researchers, and vice versa. So some of the things you see here, for instance, this is a community meeting that we did with Bob's group and Hannah here, and we're with Utqiagvik, for instance, where we're sharing food, we're having a barbecue, we're having some fun door prizes, talking about cool stuff. This is afterwards when we were having s'mores with the kids. Obviously, this is all pre-COVID. Now we're on fully virtual, and just crossing our fingers someday that we could do this all again. But that's kind of my position, is to help facilitate these relations. And the last part that I kind of wanted to get into was to tell you guys about the extreme variation in the Arctic as far as native cultures. The Arctic is so huge and so big, and it has these huge oceans, and the terrain is just incredibly difficult to cross and all that. So you have this just intricate map here of Indigenous peoples across the Arctic, and the cultural variation is just amazing. The thing is that we're dealing with a lot of threats that are very similar as far as environmental threats. Dealing with the coastal erosion, the loss of sea ice, our melting nuna. The land, the nuna is melting permafrost. We're all dealing with a lot of the similar threats, but we're forced to face these threats in very different ways. For instance, living in different countries, or the geographical location of a village. Are you on a riverbank? Are you on a barrier reef island that's made up of sand? Are you on solid bedrock on a mountain? So it does vary quite a bit. And like I said, we're kind of, the socioeconomic situation also does vary. There are some places, for instance, the North Slope, where we have some oil development, the local taxing. There might be other areas that are not quite as, don't have that tax structure, for instance. In Alaska, and make sure I'm not going over my time here. In Alaska, it's the cultural variation is extremely complex. Again, just to reemphasize that, and this is not a small location or anything. This is a huge and expansive, and so many different environments that it's really hard to reflect here. But I just wanted to reemphasize how complicated it is. Generally, in Alaska speaking, you have the Inuit, Inupiaq, the quote-unquote Eskimo groups, where my roots are on the coastal areas, and then you have a variety of Dene folks and southeast Indians who have been around for a very long time and have ties to to the south as well, and lots of ties in Canada as well as down in the lower 48 states. And just very briefly, I was going to tell you kind of how 3 villages that I've kind of spent a lot of time in and grew up in, how they've been dealing with these threats kind of similarly, and kind of the situation, how they're similar, I guess. So like the location of villages, generally speaking, a lot of them are in very optimal places to do subsistence gathering. For instance, Utqiagvik, where we are, like I said, when we were hovering above Utqiagvik here, looking out towards Narl, where our base is, and this is the northernmost point in the United States here. This is the location where bowhead whales cross on their spring trip over to the Beaufort, and then on their fall trip. So they kind of cross right here on the point here, and they go from point to point too. So it's very optimal for us to catch our muktuk and the whales that sustains the people. But we are also facing, these are optimal locations, but they're also facing this incredible coastal erosion, which is kind of a feedback loop, like Bob said about the loss of sea ice. These pictures right here reflect, number one, how deep our history is, but number two, how threatened we are to these one-time storm events. For instance, in this case, this is a Wolokpa that's just right down the coast from Barrow right here, Utqiagvik, and it's probably about 2,000 years of continuous occupation here, and it's a site on our land, on UIC land, so we take care of it. But this just shows that one of the houses started to show here from eroding bluff, and then this was a year later, but this was all from one storm pretty much. You see the storms when they hit the bank, it basically undercut the entire site. We had plastic kind of covering it. It got jumbled up in there, but basically we're pulling remains of our ancestors out and kind of trying to manage these sites, but just to emphasize how much these one-time storm events could really have impact on our communities, but also to emphasize our very, very deep history. We have up to 5,000-year-old remains there. The 3 villages, really quickly, this is the last slide, is that where I kind of grew up, was just to show you that coastal villages in Alaska, one thing is that yes, we are facing these big issues, like down here in Utqiagvik, like I said. This is a seawall that was being built during a big storm just to try to protect Utqiagvik. The problem is that you can't just up and move like we might have been able to in the past. As you can see here, we're exclusively surrounded by 23 million acres of federal conservation land that was kind of taken without our consent in the 1920s. So you can't just up and move. We're kind of landlocked into where we are. The same exact story for Shishmaref here, where people were forced to move to bring their kids to school, and it was actually where the government school was built on a barrier reef island, where people only went out there in the summertime just to dry fish and dry meat and to get away from the bugs. And there were some sod houses around, but basically when the guys came on the ship and they said, okay, that's where everybody is, and they came and built the school there and forced everyone to move into this barrier reef island kind of community, and now they're faced with being landlocked, completely exclusively surrounded by a national federal conservation land. And then Unalakleet is where I grew up, and similar story, on the coast, dealing with flooding, a little bit more flexibility with a little bit more public land there to deal with, but also surrounded by kind of that conservation land. So that's one big aspect as far as just up and moving communities. We're kind of landlocked in with state and federal land after the land claims. So just to review very quickly, I gave you an idea of what we do as logistics providers, Indigenous logistics providers specifically. A huge part of that was acquiring the infrastructure. So we have so many brothers and sisters and relatives and everywhere who are Indigenous folks it's just that infrastructure to host the scientists and do the thing. We're very lucky that our leaders before us really acquired that Naval Arctic Research Laboratories and continued to build there. The paradigm shift in Arctic research is really starting to become more inclusive and really pushing for more actionable research, which I think the funders and scientists are really responding to, but COVID-19 is making it really hard, obviously, for everything. Local perspectives, I gave you a few aspects of how we're dealing with things in different communities and kind of the similar threats and some of the similar circumstances we might have across the coastal communities. So, thank you very much, and I will stop sharing.
Well, Bob and Corey, thank you very much. Wow, there is plenty to talk about. And for those of you listening, You can type your questions into the YouTube comments section, or you can text them to 616-308-6560 to join in the conversation. And I guess if both of you could, and Corey talked about this a little bit as he completed his section, but so climate change, what are the number one concerns, the number one impact to people, both in Michigan and in Alaska, for what's happening, and this incredible increase in the warming Arctic? What are a couple of the things that immediately come to mind in terms of impact on daily life? And Bob, why don't you take, why don't you take Michigan a little bit? I know you could also speak to Alaska in your research there, but what are folks around here? And I mean, is Texas situation from the winter? I've seen some debate about that, whether that's a cause or not a cause or whatever. What are some of your immediate thoughts about impact on people?
Well, the weather is so unpredictable, but it's much more unpredictable now. And a lot of people think of climate change as raising the average temperature, and that's true to some extent, but that you'd call global warming, and it has an impact, but really it's that change that's the bigger issue. And it used to be that the average was more it was a bigger bell curve, and now it's a more narrow bell curve. And so you could still have the same mean temperature, but have more variability. And that's what's predicted and has happened with climate change. So was Texas due to climate change? Well, you could get in a big argument, and I don't want to, go there. But certainly events like what happened in Texas with the polar vortex are totally consistent with climate change. So totally predicted from it. The polar vortex is, normally you'd have the polar climate kind of more contained. There's more, and as you warm that region, it's less contained, if you will. It's particularly warming at the higher atmosphere, but you could get in a whole debate over that. When you talk about any specific location, it gets really dicey. I don't know if you guys remember, you're a bunch of educated people, and you probably remember a few years ago, everyone was talking about Great Lake levels going down with climate change. And no one talks about that now because they went back up. So I really hate to get too specific. The bigger issue is the huge variability that I think that it's very predictable that you'd have lower lake levels and higher lake levels. You'd have bigger droughts and bigger floods. Certainly hurricanes. This last summer we were all focused on COVID, but it was a horrific hurricane season. So around here, I would think it's that variability, the bigger storms is the bigger impact. But to say one event, no, you really can't do that. You have to take an average over a long time. And I'll let Corey talk about Alaska.
Yeah, actually, I had the exact same thought that popped in my head, and over time, this extreme variability that we're facing, it's become very scary, and it's not just happening in the Arctic. Like if you're going to have a extremely wet year, for instance, flooding, that kind of thing. But then the extremely dry year, for instance, the next year, and then forest fires and all that stuff. So I think it's not just in the Arctic. As far as like in the Arctic, though, one thing that we're facing is the permafrost thaw, obviously, for the foundation for a lot of our villages. Point Lay is a clear example of that entire village. Literally, you build a house, it's getting so bad that it's sliding down the slope, and in that case we do have several science projects that are funded actually that are interdisciplinary, where they're bringing in civil engineers and they're bringing in the permafrost scientists, and we're very happy about that. However, that's one of the biggest issues that we see on a big scale. That's not happening in all a lot of the villages that are facing that same issue or don't have scientists coming in and working, for instance, on that. But in that case, we do. So the kind of the melting, or I get correct all the time, thawing permafrost or melting permafrost, or the melting permafrost underneath our feet is a huge issue. The drying of some lands, like we call it the ice plugs when the lakes drain, for instance. And then Arctic shipping is another one that we're getting more and more concerned about. Our neighbors to the east of us, I should say west of us, I'm sorry. For instance, Russia is sending these light, what are they called? I don't know exactly what they refer to them, but they're just this year, their first time they're starting to send these big oil tankers in through the Arctic full speed that are kind of like these light icebreakers. They're just blasting right through the ice without what do you call it, the tugboats that kind of assist them on the way. So that's something that we're very concerned about in the Bering Straits region, is this uptick in petroleum movement through the ice. And one big disaster could be very catastrophic because that oil doesn't break down, for instance, in the cold weather like it does in the warmer weather. So yeah, definitely thawing. It's the variable weather. Nothing, we don't know what to expect. The erosion of our land, of our foundations of our buildings. There's places like Point Lay, for instance, that is a really bad example. The Arctic shipping, and then the last thing that I'll mention is the animals. The animals, some of them are under extreme stress in certain areas in the northern Bering Sea. They're seeing this total ecosystem collapse from the lack of the sea ice. So depending on where you are, you could be in a huge world of hurt if you're facing these very variable circumstances.
Wow, thank you both for that daunting issues. Here's a listener maybe trying to think positively in all this. Does the warming provide opportunity for agriculture production? That's an interesting question. Either one of you want to take that one?
Well, as a botanist, yes, but not so much in the Arctic. The Canada is happy in a lot of ways. North of the Dakotas and stuff, that the breadbasket will move there. A lot of Russia would be happy as well. One of my Russian friends that I went to grad school with, drinking buddy, would giggle and say, yeah, we knew about climate change for a long time, but we didn't say anything because they were going to have the benefits of agriculture and stuff. But lower Alaska, yes, but not the Arctic. That said, though, as they energy is cheaper and so forth, there's greenhouses, and there's some talk of some local communities making their own vegetables, but those would be in greenhouses that are kind of isolated from the climate.
I will say that this isn't in regards to agriculture, but as far as resources, a bulk of it is, yes, it is doom and gloom. It is very, very scary for our people. However, there are things here and there that, for instance, in the YK Delta, one of the biggest tributaries in the U.S., the Yukon-Kuskokwim Delta in southwest Alaska, the shrubs are growing bigger. People, I've heard from friends that have grown up there, they said, we used to be that tall, now they're, and the moose are moving in really big numbers. It's one of the most heavily populated areas for moose, which is a great food resource. Although culturally it might be harder to get used to for a little while, going from caribou to moose, the skinny guys to the big, more gamey meat. But that's one benefit, for instance. Another one is that, with the more opening water in the Arctic Ocean, which is extremely bad for our coast and for a lot of reasons, they are seeing the bowhead whale population, and also for now the polar bear population doing really well in our areas because of the more open water, more plankton, more, I'm not a scientist, but basically there's more organic material being developed, from the sunlight, algae, I should say, maybe. But for some reason, for instance, the bowhead whale population is doing really good, but you can't really, if that's the cause that it's opening up, there's also other things that are, for instance, the killer whales are starting to come up into the Arctic, which are could cause a bowhead well crash, for instance, because so it could bubble and then crash in that case. But and I've heard of traditional stories from my friends in some of the villages tell me that one of them told me that his grandpa always told him that before a certain population of animals or anything crashes, it always gets really big right before. So that's kind of one thing that kind of concerning. But there are a few little things here and there that are positive things about it. But in the big picture, it's something that we really have to take on I think it's going to take a whole country effort. I think that's why it's important to talk to you guys, because you guys are our fellow citizens down south.
A question about mention of positive feedback in carbon release. What about methane release from melting permafrost? Must be a biologist question.
Yep. I deleted my picture of blowing up methane just because you have carbon release. So as the carbon breaks down, if you're in dry soils, it's released as carbon dioxide. If you're in wet soils, it's released as methane. So much of the tundra is actually turning into methane instead of carbon dioxide, but they're both potent greenhouse gases. So in wetter areas, it would be methane. You can actually see those really well. This would happen naturally, but it's happening more. Sometimes you'll see bubbles, even around lakes around here. If it freezes real clear, you can see bubbles under the ice. Those would be methane bubbles that are trapped. You can pop into those and light them on fire. And there are some places by Akasuk where they've always been, and some lakes where there's always like a hole I shouldn't say a hole, but a hole in the ice where there's so much bubbling that normally happens that's just always been that way. They've actually gone and measured throughout the Arctic and looked at the carbon signature, like the isotope signature, and seen that the carbon that was broken down is old. And there's lots of ways to do that. The cheapest way is just to look to see from nuclear testing. So it's really easy to see like pre-nuclear testing, post-nuclear testing. You can also look at it in much more detail, but that's a cheap, easy measurement. And there's lots of places throughout the Arctic that show that recent release of both carbon dioxide and methane is pre-nuclear testing. And then there's been more detailed ones that show that some of them are 10, 20, 30,000 years old.
There's a
question. Go ahead, Corey.
I was just going to throw in a couple little tidbits of interesting facts. There was a big glacier or underground glacier impact crater near Utqiagvik, where it created these kind of big these crumples in the earth crust or something where there was gaps, and that's where the natural gas that's where we get our natural gas we use in Barrow in Alaska. We have like 6,000 people there, so it's quite a bit of gas. But then the other thing I was going to say to keep in mind as well is that for those that are interested in the oil industry, northern Alaska is just covered with, the central part of northern Alaska where the state land was on the North Slope. Just, the oil rigs are everywhere. The oil fields, the two largest oil fields in the U.S. are there. And what they do there is they pump treated ocean water into the oil wells to create more pressure to push the crude oil up. So you're actually pumping organic material down there, and then what you have is, Bob, correct me if I'm wrong, this might be just I'm getting carried away with my theory here, but the H2S gas that's seeping through the tundra, and that's the first thing you go through when you go to oil field training, is that you do not get into any holes in the ground or anything, because the H2S gas is seeping up through the tundra. And the pumping of organic materials, where they're pumping millions of gallons of seawater down into the bottom, deep down there, and that cooking and pushing that burning organic material. Maybe we could have another hour on this, Bob, sometime.
Yep.
Yeah, I was wondering about the oil production and how that plays into all of what you've just talked about. So that's Corey's comment. Apparently, yes, that's a factor in there too.
Yeah, and certainly the idea of offshore, the idea of developing offshore in the sea ice regions was not really feasible before when the ice was super thick. Now that it's thinner, it's a viable option. It's very expensive though. And with gas as cheap as it is right now, it's Obama actually made it, opened up some of the, offshore leasing and so forth, which was a carryover from Bush before him. And it, it just hasn't materialized because it's so expensive.
Question here. I'm very curious about the idea that villages are locked because of nationally protected land. That was a very interesting point that Corey made, I think new to a lot of people. But some folks there need help because of climate change. And in other words, got a natural disaster going, and usually affected communities receive some aid. But has there been any conversation with the government around this? Are these communities that are locked by government-owned land? Is there any conversation going on for government recognition of what's happening and other options for people in those communities?
Yeah, I'm just full disclosure. I'm nowhere near a professional on all this, but I do know that there has been some really good efforts. I know that, for instance, Shishmaref, who is facing relocation, was they already have an area that's feasible to move to, and I do know that certain cases it's the government. They work together with the local tribes and all that. But in the big picture, I could tell you that my 20 years of kind of working in Alaska Native politics and studying and getting a master's in cultural anthropology that focused on Alaska history, Native history, political history, that people across Alaska are not happy about the land claims era, and kind of how when that oil was found on the North Slope, those oil companies and the feds and the state and everybody wanted to get to it badly, so they started just divvying up the land amongst themselves. We had to fight like heck just to get that to stop and just to consider our views. We ended up with 44 million acres to split up amongst all natives in Alaska. That's about 10% of Alaska. 220 million acres went into federal lands. The state of Alaska got 130 some million acres to divvy up. The state was going after only resource-rich lands, which are that correlate a lot with our traditional lands. And the state constitution said that in order for us to take these state lands, it has to be vacant. Vacant meant non-developed. And if you go out to our fish camps and our villages and all that, and that's not developed in their terms, we don't have the skyscrapers and this and that. So they're coming in and taking that land. And it took us, our leaders who are very visionary, Ukpeaġvik Erickson and others, to go down to Congress and go bang on the door of the Secretary of Interior, Stuart Udall, in 1969 or whatever. And he was the one that came in and put a stop to all this and put the land freeze in and said, oil companies, state, everybody who's licking your chops, stop what you're doing until you figure out and make a settlement with these natives here, because you're screwing them over too much. So what they did was they went through these, in light speed, they wrote the Alaska Native Claims Settlement Act. They were able to solicit the signatures of some leaders at that time, but it wasn't something that we agreed to on a statewide basis. And now we're stuck with that legislation where we have a very small piece of the pie, and we're completely surrounded and engulfed in these federal conservation lands, these state lands that are being produced or mined or oil drilled or whatever. So that's what I'm saying, is that there's a lot of people widespread are not happy about that, how it played out, and we're facing the repercussions right now. And but one of those is being landlocked.
Well, and the way insurance works is after the fact. So it's really hard to get money before an event. So it's a weird catch-22 that that this community is going to be wiped out, but you have to wait until it is before you can do stuff. So and it's exceedingly expensive. Living in these cold areas, you do a cheap sewer, it would freeze. So there's a lot of infrastructure that goes into these communities that have accumulated over a long, long time.
There's a question from a listener. Does more green in the Arctic decrease carbon in the carbon environment, like planting trees?
Okay, so in general, as you warm, you'll get more biomass, more plants. Certainly, a forest has more biomass than grassland or a shrubland, but there's this organic matter that's in the soil that's been accumulated over hundreds of thousands of years that that just has more. There's more carbon in the soils of the tundra than there is the trees of the rainforest. So so the balance will, there was some debate, but all the indicators are, and it depends on where you're at, but most of the indicators, on average, you'll have a net loss of carbon. Despite having more plants, you just have more breakdown. That's the on average.
Yeah. Thanks for that. Question probably for Corey. Fascinated by the partnership model that exists between the local community and the scientific community. Are local students encouraged or sponsored to become scientists themselves?
Yeah, that's been kind of one of my main missions for many years, is to really try to use the what we have in our backyard and inspire the students to, number one, become scientists. Work in the a lot of the as Bob would attest, I'm sure, a lot of these research institutions would love to have folks from the villages and more in their classrooms, but also on the logistical business side of it, Arctic research is incredibly expensive, and if you don't have that capacity locally, a lot of times it's brought in from outside. So I tell a lot of the folks too, is let's get our stuff together and it might be ready, and start so that's, we're in the current works of really trying to really plant the seeds for that generation of maybe even like a system of privately owned logistics providers is my dream. Have a bunch of UIC sciences all around, but so that we're working towards that, and we do work very extensively with the schools. In fact, that's my biggest passion is education with the K through 12 kids, and we have big science fairs. The pictures that you saw earlier, Bob's group really contributed to that as well. But we bring. What happened before was scientists would come in and they would a lot of times want to present their research to check the box off to say, okay, I shared my research, now I can go back to my institution and tell the funders I shared with the community, kind of thing. That was check the box research, and they kind of came in at different times, kind of drop in, drop out. So our thing for the last 5 years was coordination and collaboration regardless of affiliation. You bring everybody together, and we have this 3-day event where we have 30 different scientists coming in groups, and they do all their outreach and engagement for that 3 days, not necessarily all the relationship building, but like sharing with the community, sharing time, having a barbecue, working with the kids, and so that the community has something to look forward to, and they're not burdened with that meeting fatigue. You hear about that in Utqiagvik, because in order to keep up with all the science going around us, previously the locals had to go to this meeting every week for 2 weeks, for every science project having their own evening seminar kind of thing. So what we do is bring it all together, consolidate it all together, and then try to make it so it's something that the locals can look forward to, but then also the scientists could look forward to. And that's our goal, to get back to that. But COVID-19 has thrown a lot of wrenches in it, and so we're stuck with doing a lot of virtual stuff, but it slowly getting back to that, hopefully someday.
Someone asking a question about extreme weather events, and wondering maybe humans can respond to that anticipated variability perhaps better than animals and plants. So wondering, of course the brunt falls on all people and animals and plants, whatever, but wondering, are animals and plants particularly endangered by this climate variability? Because they can't listen to Bob's lecture, and they can't go to the stuff that Corey puts together so people will know about this. They have to endure it.
So yeah. I will say, though, that the Arctic has so much variability, historically has, that in some ways they're pre-adapted to be more flexible, if you will. Some people would make an argument that tropical ecosystems are actually more susceptible because they have no history of variability. But absolutely, it's those extreme events that are more likely to wipe out populations. just as a fun aside, sugar maples. I mean, we're just finishing sugar maple season, if you will. The kids were popping or tapping sugar maples a couple weeks ago. Sugar maples, we're right in the middle of their distribution. 100 years from now, their distribution is not expected to be in Michigan. So we're talking, some pretty major changes. What'll probably happen is not that they all like slowly die one tree at a time or whatever. It'll probably be some big event where they're stressed out and die from either an extreme weather event or makes them susceptible, and then a disease comes in. And, one of the things when we talk about, caribou and moose and so forth, it's not necessarily the temperature, it's then the temperature and the parasites, the ticks and stuff that they get. So, but yes, the animals and plants will be very, and they'll each respond individually. So it's really hard to predict.
Yeah, and one thing that I will say is that a couple of years ago, PBS Nova came in and they were doing a docu-series recording, and they asked, could we interview some scientists or some whaling captains? So we had them sit down with some of the whaling captains, and that was one of the first questions they asked was, how do you feel about how the animals and the sea mammals are responding to this climate change? Do you feel? And what he said is something that I also had heard from others too in the Native community, was that, believe it or not, the animals are always 2 or 3 steps ahead of us. Some of them are in very dire circumstances. The walrus need that ice to be able to live on. They can't live off of the beach by Point Lay for instance. But that's what the whaling captain said was, they're how many steps ahead of us. We're seeing the impacts after the fact, and just have to look at it that way too, that they're responding to something that we don't even know might be going to be happening here in the future, close future.
That's a great point. And looks like we have some polar bear fans here too, and wanting to know about what life is like for them now, and if there's, what are some of the particular dangers that that grand and great animal faces.
Yeah, I'll say that from secondary hearing a lot from the scientists, and that the scientists are very cautiously watching the populations, and the population that's in the Beaufort area, because they have like different kind of population areas, not really subspecies but different kind of location areas. The polar bears that are in the Beaufort Sea, for instance, their population is doing really good, and that's kind of, if you look at Utqiagvik, where we said earlier, that's kind of right in the middle of Alaska. Everything east of it is the Beaufort Sea towards Canada. Everything west of it towards Russia is in the Arctic Ocean is the Chukchi Sea. The Beaufort Sea population is actually doing really good. The Chukchi Sea population, where it's more on the shelf and there's less ice, doesn't look like it's doing as good, but still it hasn't crashed, I don't think. And one thing I always like to say about the Nanuks, the polar bears, is that they're not like real crazily aggressive like the brown bear or black bears that will just kind of charge you, or they're just, I just like how they're kind of just cool and collected, and they try to avoid conflict for the most part unless they're really hungry. But if they're around whaling crews or they're around whaling, that probably means that they're already full because they ate some ukruk or some stuff that was set aside from the whale, or some remains. They might already be full, and they don't want to cause no trouble, so they're kind of just lounging around. But they are still very dangerous, and you always have to kind of watch out for them.
Wow, here's a ponderous question. Is it too late to save the Arctic as we knew it? Are we beyond a point of no return, or are there things that we can do?
It's not too late. But that being said, in a lot of ways, we're paying for our sins from 20, 30 years ago. So it'll be a while. If you look at ozone as the big success story, that, in the 1990, we mostly eliminated ozone depleting substances. It'll still be another 40 years before it really recovers. So these are long-term, so no, it's not too late.
And I'll repeat another thing what an elder, kind of a person I really look up to in Utqiagvik. The mayor of the borough, Harry Brower, he says that when we approached him and he saw kind of some of the terminology, like the navigating the new Arctic, he always gets kind of irked because he's like, this is not new for anybody. This is people. What I missed in the presentation that I wanted to say was that we've dealt with some of the most variable environment and extreme weather changes for thousands and thousands of years in the Arctic. Even from year to year, it could be very, very variable. We are noticing that it is even more variable now. However, we have extremely resilient people, and we're not going anywhere. The Arctic's, we're still going to have those cold winters. Yes, we might have more open water in the Bering Sea during the winter, and that's a huge, scary thought. But at the same time, it's still going to be this frozen, solid Arctic, for many part of the year. Like we've had a very, very cold year this year, for instance. I mean, one of the most coldest years, in a while on as far as the temperature. We had the most snow we ever had on the North Slope, I think, ever measured like 3 or 4 years ago. For instance, the variability is kind of all over. So we're not going anywhere. It's going to continue to have these cyclical freeze ups, but there are some things that we have to pay attention to that we talked about today.
We're about ready to wrap up our time, but here's an interesting question. The new Secretary of the Interior is a Native American, first time that has ever happened in the history of the United States. If you had an appointment with her for a bit of time to talk about the Arctic, what advice or what kinds of things would you talk to her about?
Or I'm sure you could talk her ear off with all the people you talk to up there. So I'll give you the floor.
I probably wouldn't. I would when it comes to these kind of things where I get really nervous and scared of what I'm going to do. What I resort to is just chilling out, throwing the agenda out in the trash, and just inviting her to come try some muck duck, or just to tell her about some hunting and gathering experiences that our family are currently doing, and then just kind of open it up from there. But I think she's going to be. There are a lot of people in other positions for myself. I'm there to kind of engage scientists with the communities as far as driving policy. We have some incredible leaders in the Alaska Native community. I can go through a long list of colleagues that are actively working on how they are going to approach Secretary of Interior Deb Haaland, because she and I've heard these meetings. They're ongoing every day. Things are developing. People are really going to strategically really try to work with her, and not quite my job, but I am aware of the excitement. Yep.
Wow, it's great. Boy, we've learned a lot. How can our listeners keep up with each of you? Hey, Bob can start, and then we'll go to Corey. How can they keep up with what you're doing? Stay in touch with the research, get hints on maybe ways they can become involved or learn more about this very, very important part of the globe, and how they maybe could get involved personally. How can they follow all that, Bob?
Yep. My research program has a webpage. It's just the GVSU webpage / Arctic Ecology Program, AEP. So that's a really easy, it's gvsu.edu /AEP. Then I've got links to a bunch of other climate change related and environmental science. So it's I try to make it my one-stop shopping. So that's a great one. The Arctic Report Card is a really good, if you just type in Arctic Report Card, that's a great resource that talks about changes in the Arctic. You can always email me. Those would be great ways.
And those a lot of those graphs and those maps that you showed in your PowerPoint, if they went to your site at GVSU, they could find some of those kinds of things and more.
they could find some of those. They could actually email me, and I'd be happy to share a lot of those. Those are from a lot of my lectures as an environmental science teacher. And I've got some of that. Yeah, a lot of that's on that webpage.
Corey?
Yeah, so we're actually working on making stuff more accessible to folks outside of kind of our realm. One thing is that we're actively working with fellow team members, the Battelle Arctic Research Operations, the Battelle ARO is the office, and that's kind of the science logistics contract to kind of help plan and implement a lot of the National Science Foundation research. And so that eventually you'll it's not quite fully launched yet, but it's called the Battelle Arctic Gateway, and that's where we'll have updates as far as any of the NSF affiliated research we're doing, and that's kind of a bulk of what I've been working on lately. And then we'll also have a series of podcast episodes that we're just going to start the production of. So it'll be monthly podcast episodes highlighting areas of our program and scientists that we work with. Bob, I need to schedule a date with you on that front. But anyway, yeah. So the Battelle Arctic Gateway is one place to find it. Then also we're trying to work on our UIC science kind of platform online as well. Eventually, the Ukpeaġvik Inupiat Corporation. If you don't know how to spell that, email Bob. He'll connect you. I'm kidding. But yeah, you can find us online. You look up my name or UIC Science, and we're not too hard to find. Hopefully, we'll have our social media game up to par in the next year as well. So.
Well, it's marvelous. Thank you both very much. This has been very enlightening. And yeah, some folks have been commenting, wow, this is, it's depressing. This is really difficult, tough stuff. But I think one thing that's been really wonderful to observe between the two of you is this great partnership between Indigenous people in Alaska, the work that Corey's doing, and Bob, your work with ITEX and the way there's cooperation. There seems to be greater and better proactive cooperation between scientists and the people who live in the Arctic. So that's been marvelous, and I think a lot of things that our listeners didn't know about. At least we can take some encouragement from that.
Thank you.
Yeah, for sure. Thank you, and book to both you guys for everyone for hosting, and it's a real honor to move forward in this world with everybody, because I think we're in the right spot and the right time to do some of this. And scientists, funders, everybody wants to do the right thing here. We just got to figure out how to kind of do it. So thanks.
Great. Well, thanks for the information, for inspiring us with your partnership. And folks, if you would like to talk more about this, on Wednesday at 7 o'clock, we have our next edition of the Global Mixer. You can go to worldmichigan.org/Great Decisions 2021. Sign up for our local mixer this Wednesday at 7. We're going to keep talking about the topics that Corey and Bob brought up, and other topics about the world that you want to speak about. Join us a week from today when we're going to shift from the Arctic to Africa, and we're going to talk about China in Africa a week from today at 6 o'clock in our Great Decisions program. So thanks so much. Please like our YouTube page while you're there, and we'll see you again soon.